most tragic period of human history, explosion of atom bomb in the Second World War. But do you know, at that time, the most famous scientist was crying in a jail. He never thought one day his theory would destroy the human civilization. According to him, science and technology should be used for the betterment of human being, not for destroying the human being. Do you know who was the scientist? He was the most famous Ernest Rutherford. So I think all of you understand very well what will be the today's topic. Yes, today we will discuss about the atomic structure. Myself, Tanmoy Dotto, Assistant Professor, JS College of Engineering, Kollam. Today we will discuss about the first lecture of atomic structure, which is included in the chemistry syllabus in module 1 of BTech first year course. We will discuss Rutherford's model, its drawbacks, then Bohr's model, the application of Bohr's model, and the drawbacks of the Bohr's model. So without further delay, let's go to the class. That invention started from India. Do you know? It was the time of around 500 BC. The great Indian philosopher Maharishi Kanad suggested that if we start to divide a matter, then there will be a time when we can't break the matter further. And according to Maharishi Kanad, that particles are called in Indian language Parmatu. After that, the great Greek philosopher, the two great Greek philosophers came to the field and followed the same pathway that was followed by the Maharishi Kanad. They also told that if we started to break down the matter, then there will be some tiny particles which we can't break further. Democritus first introduced the concept of atom. Democritus named that small particles are atoms. Atomos means individual. Then in the end of 18th century, so many scientists came to the field and introduced different kinds of concept of atom. And finally, Rutherford came to the field and introduced a new concept of atomic structure. But for that, Rutherford did one very famous experiment. The experiment was alpha scattering gold foil experiment. Before the Rutherford's atomic model, there was one famous model widely accepted. That was plum pudding model, that introduced by the Thomson. In the plum pudding model, negative charge are on the positive charge. But the experimental results was not satisfactory according to the plum pudding model. So there was a time when it was very much required to introduce a new atomic model. Then Rutherford came to the field and Rutherford did one experiment. According to Rutherford experiment, that was called alpha ray scattering gold foil experiment, in this experimental setup there was a source of alpha ray, and that source, that alpha ray source, that was bound in the lead container, and in that lead container there was a small hole. In that small hole, the alpha ray can pass or can go through a straight line or straight pathway. And why Rutherford used the alpha ray? Because alpha ray very much high energy. Alpha ray was the helium nucleus, that means He2 plus ion. And according to plum pudding model, Rutherford thought that all the alpha particles that should go through gold foil. And that's why Rutherford used the gold foil. Rutherford used the gold foil because gold foil, that is very thin and it is approximately made by the 1000 atoms. And there is a band also. Band means it is actually detected. If the alpha ray pass through the gold foil, then the alpha ray hit to the detector, and detector actually fluorescent screen. That means alpha ray hit the fluorescent screen and it will glow. So that's why there is an expectation from the Rutherford that according to, if the plum pudding model was right, then all the alpha ray should pass through the gold foil, and all the alpha rays should pass or should go in a straight line. But actually it not happened. Maximum of the alpha particles pass through the gold foil without any obstacle. Few alpha particles deflected in a particular angle, and very few alpha particles came back to its original pathway, that are called rebounded particles. So Rutherford put one. Rutherford's model consists of the 4 postulates which explain the inner structure of the atom. According to the Rutherford's postulate, according to that is also called Rutherford's model. So better will use the term Rutherford's model. So according to Rutherford, there are 4 postulates. That means there are 4 observations. So what is the first observation or the first postulate? So Rutherford told that in the center part of the atom there are heavy mass nucleus, and nucleus that carry the positive charge. So according to Rutherford, that in the center part of the atom, here is it is the center part of the atom, and center part of the atom there heavy nucleus. Heavy means heavy dense, very high dense, okay, or heavy dense. The heavy dense nucleus exists. And then Rutherford told that maximum part of the atom, that is the vacant. Second postulate of Rutherford's model, the maximum part of the atom that is vacant. Why Rutherford placed such kind of postulate? Because in the alpha scattering gold foil experiment, there was an observation that maximum alpha ray passed through the gold foil without any obstacle. So that means if the maximum part of the atoms are not vacant, then it was not possible. So Rutherford told that nucleus has the very high density. High density means it has the heavy mass, but size is very, very low with respect to the overall size of the atom. So first postulate that Rutherford established, that is the nucleus exists. Nucleus means very heavy dense nucleus. The nucleus exists in the center of the atom, which is actually positive charge, and maximum part of the atom that is vacant. Third postulate, that is also very, very important. The third postulate, according to the third postulate of the Rutherford, that electrons revolve around the nucleus. Electrons revolves around the nucleus, and that electrons are negatively charged. So already Rutherford told that in the center there is a nucleus, a heavy dense nucleus, and that nucleus carry positive charge. Now electrons revolves around the nucleus and it carry negative charge. And according to Rutherford, that total amount of negative charge and total amount of positive charge, that are exactly equal, and that's why we are getting the neutral atom. That's why we are getting neutral atom. So these are the 3 main postulates. Now come to the 4 postulates of the Rutherford's model. Actually Rutherford explained the stability of the atom. According to Rutherford, if any electron revolves around the nucleus, then there are 2 forces which are acting in the opposite direction. That means there is an inward Coulombic attraction force, all of you know very well, that is the negative charge. So negative charge, positive charge, there must be some kinds of Coulombic attraction force, and there was also some centrifugal force which acting outward direction. So according to Rutherford, that outward centrifugal force and inward Coulombic attraction force, that are exactly equal and in opposite direction. And that's why atoms are stable. Stable means electron will not jump on the nucleus, and that's why electron continuously revolves around the nucleus and it will not jump on the nucleus. So we are getting a stable atom. So these are the four main postulates of the Rutherford's model. First one regarding the existence of the nucleus, that means the heavy dense nucleus that exists in the center of the atom and which carry the positive charge. And second one, the maximum part of the atom that is vacant, because you know that alpha particles pass through the gold foil without any obstacle, maximum alpha particles. So maximum vacant because the size of the nucleus, that is very very small, that is a high density, that is heavy mass, very small size with respect to the overall size of the atom. Third postulate, electrons revolves around the nucleus, and that electrons are negatively charged, and that's why the total amount of negative charge and the positive charge which exist in the nucleus, both are equal, and that's why we are getting the stable nuclei. And the fourth one and the most important one regarding the stability of the atom. In the stability of the atom, the Rutherford told that the inward Coulombic attraction force and the outward centrifugal force, this is the Coulombic attraction force, this is the Coulombic attraction force, and this is the centrifugal force, this is the centrifugal force, they are acting in opposite direction, and that's why we are getting a stable atom. So these all are the postulates of the Rutherford's model. There are some advantages of the Rutherford's model. So first of all, that Rutherford's model first explain the existence of nuclei, or some kinds of model more realistic. Okay, previously before the Rutherford, that what model was there, that was not satisfactory result scientists obtained from that model. So, but that model also suffers from the serious limitations. Now come to the point, what are the drawbacks of the Rutherford's model? You know, Rutherford's model, it is not free from the limitations. There are very crucial drawbacks, that means drawbacks regarding on the from the point of view of stability, and another drawbacks regarding spectra or spectrum of the atom. Okay, so there are mainly two drawbacks from the point of view of stability, and another is the spectrum. So first, stability. Rutherford explained the stability of the atom from the point of view of centrifugal force and the electrostatic attraction force. But what is the actual phenomenon? So according to electromagnetic theory, if any charged particle revolve another charged particle with acceleration, then it continuously emits the energy. Here what happened, one charged particle is the electron, another charged particle is the nucleus. So when electron revolves around the nucleus, according to electromagnetic theory, it should emit the energy. That means its velocity will be decreased, and on the other hand, its electrostatic attraction force remains same, but outward direction force, that will be decreased gradually. So that means electron will jump on the nucleus in a spiral pathway. So that means what Rutherford explained regarding the stability of the atom, that was not right. That means according to the practical scenario, if electron jump on the nucleus, then what happened? The total system will collapse. That means we can't explain the stability of the atom. So this is the first drawback of the Rutherford's model. So second drawback regarding the spectrum. Okay, first drawback stability, second drawback regarding the spectrum. So according to Rutherford's model, or according to that theory, if electron continuously emit the energy, we should get the continuous spectra. We should get the continuous spectrum. But actually we will get the line spectrum from the atom. Spectrum means when a continuous light or a light passes through any device, by that one by one particular wavelength will be splitted, and if we detect the band or detect the each and every individual wavelength, then what we are getting, that is called actually spectrum. Okay, now here what is the, in case of the white light, that means which is coming from the sun, then what happened, that actually we are getting a band of the colors. You know, all of you see the rainbow actually. So that band, or that one by one color, overlapping color, that is called actually continuous spectrum. Continuous spectrum. And what is the line spectrum or discontinuous spectrum? If here there will be a dark region between the two successive color, then suppose it is one color and there is the another color. So if that in between that two there is some dark region, then again there is some dark region. Again we are getting another color. Again we are getting another color. Okay. Then that kind of spectra is called actually line spectra. That means here one by one line we will get, instead of getting a band means there are overlapping colors with each other. Instead of getting that, we will get one by one line. Line means why we are getting here lines and why we are getting the band of the colors. So what is the difference between that two? Why it is discontinuous, why it is continuous? So that continuous and discontinuous all are emission spectrum. Emission spectrum means why it is called emission spectrum? Emission spectrum because the source that emit the radiation. The source that emit the radiation, that's why we are getting the spectra. That's why we are getting the spectra. That's why the continuous, or it is the line, or discontinuous, both types of spectra in the category of the emission spectra. Emission spectrum. In the category of emission spectrum, continuous spectrum and the line spectrum. Now in case of emission, there may be two chances. The source may continuously emit the light. If it continuously emit the light, we will get such kind of band of colors. So that is called the continuous spectrum. So that is in the category of the continuous spectrum. But if the source do not emit the light continuously, that means if emit the light at that moment, then there will be a gap. Then again it emit the light, then again there will be a gap. So if it emit in that way, then what happen? We will get one line, but after that there will be dark region. Dark region means there will be no emission at that moment. Then again we will get one line, then again there will be a dark region, then again we will get one line. Line means it is a particular wavelength. That means what wavelength is coming from the source, that wavelength we will get as a line. That's why it is called the line spectrum, because in the two lines there are a dark region. That means at that time no energy is coming, no energy that is coming from the source. That's why it is called actually line spectrum. So continuous spectrum and line spectrum, that two are very, very important to understand some kinds of properties of the source. That means if we consider the atom, if atom continuously emit the energy, we should get, according to the concept of electromagnetic theory, what Rutherford told, if the energy continuously coming out from the atom, then atomic spectra should be like a band. So we'll get continuous spectra. It should be like a band. There will be overlapping wavelengths by one. So that should be continuous spectrum. That should be continuous spectrum. But actually we will get, or actually we get that is the line spectra. That means experimentally the atomic spectra is the line spectra. So continuous spectra, it is not obtained from the atom. So this is the another drawback of the Rutherford's model. So Rutherford's model was unable to explain the stability of the atom and the spectrum which is generated from the atom, that was not explained by the Rutherford's model. Niels Bohr came to the field. Niels Bohr modified the Rutherford's model. That means, what are the main drawbacks of the Rutherford's model regarding the stability and the spectrum? Niels Bohr successfully modified that two area or rectified the Rutherford's model. So sometimes it is also called that Rutherford's-Bohr's model. So after Rutherford, Niels Bohr came to the field and he proposed the Bohr's model. He proposed the Bohr's model. Now what is the Bohr's model? According to the Bohr's model, Bohr told that electron will revolve surround the nucleus only under particular pathway. That means if it is the nucleus, then electron will revolve surround the nucleus only under particular pathway. There must be some kinds of pathways, and that pathways are actually called, according to Niels Bohr, that pathways are called orbit or particular energy level or the energy level. Why he used the term energy level? Because that all the orbits have a particular energy. So that all the orbits have a definite energy. So that's why he used the term energy level. And electron will revolve according to or in that particular orbit. Now which electron will be in which orbit? So for that purpose there is an equation that by which that mvr equals to nh by 2 pi. According to Niels Bohr, Bohr told that the angular momentum of the electron that will be equal to nh by 2 pi. Now what is the m? M is the mass of the electron. M is the mass of the electron. What is the v? V is the velocity. V is the velocity of the electron, and r is the radius. It is the radius of the Bohr orbit. These are the actually Bohr orbit. Okay, so mvr. Now what is the n? N is the most important term here. N is the principal quantum number. N is the principal quantum number. What is the significance of principal quantum number? Principal quantum number signify the existence of orbit. That means, what is the meaning of the existence of the orbit? If n equals to 1, then it will be k orbit. For example, this is the k. So if n is equal to 1, it will be k orbit. If n is equal to 2, it will be L orbit. If n is equal to 3, it will be M orbit. And if n is equal to 4, it will be N orbit. So that means if from that equation, if there is n equal to 1, then it will be k. If n equal to 2, then it will be L, then 3, then M, and so on. Okay, and all of you know very well what is the H. H is the Planck constant. It is the Planck constant. Okay, so which electron there will be mvr equal to nh by 2 pi. So where we are getting the mvr equal to 2 pi, that relation, only that electron will be in that particular orbit. So by which, or by that concept, and this also this is the first postulate of the Bohr's model, and by which Bohr established that there will be some particular energy level that is also quantized, or the fixed energy or the definite energy of the particular pathway or the orbit, and when electron revolve in that orbit, then electron will revolve one by one orbit. Okay, now come to the second postulate of the Bohr's model. So according to Bohr, when one electron revolve in a particular energy level or in particular orbit, then it neither emit the energy nor absorb the energy. That means when one electron will be a particular orbit or revolve in a particular orbit, then there will be no emission of the energy and not absorption of the energy. That means energy of the electron will be quantized. And according to Bohr, Bohr told that the energy level, what I told that these are the energy levels. So according to Bohr, if n equal to 1, this will be k, then n equal to 2, L, then 3, m, 4, n, and according to Bohr, the energy of the orbit that increased in that order. So the energy k to L to m to n, the energy will be increased in that order. Okay, so that means when electron here, with respect to that electron, it has the higher energy. Okay, so that means the second postulate explained that up to when one electron in a particular orbit revolve in a particular orbit, it neither emit the energy nor absorb the. Next postulate. According to Niels Bohr, that if the energy increases in that order, that electron will have the higher energy, and obviously that electron will have the lower energy. Okay, so now if that electron jump from that orbit to that orbit, that means lower orbit to higher orbit, then what happens? That electron must absorb the energy. That means there will be absorption of the energy. But if that electron jump from here to here, that means from higher orbit to lower orbit, there must be emission of the energy. There must be emission of the energy or release of the energy. Because why release of the energy? Because that electron has the higher energy. So that electron must release the energy, otherwise that electron will not fit in that orbit where the energy that is lower. So there are two cases. That means if E2 is the energy of the higher orbit and E1 is the energy of the lower orbit, so when one electron jump from E2 to E1, then it must release the energy. That means E2 minus E1, that equals to h nu. So that is the another postulate of the Bohr's model. So ultimately, what we got from the Bohr's model? Bohr's model, first of all, Bohr's model clearly indicated that there will be some orbits or some energy levels through which electron revolves around the nucleus, and that energy levels, that means the orbits, have particular energy. When one electron revolves around the nucleus through the orbit, in a particular orbit, it neither emits the energy nor absorbs the energy. That means, what was the problem of the Rutherford's model? The electrons continuously emit the energy. That's why there's a problem, and that's why electron gradually jump on the nucleus in a spiral pathway. But here there is no such kind of question, as there is no emission of the energy continuously. So that means here we successfully explain the existence or the stability of the atom. Okay, and then according to Bohr's model, there are energy level and the energy of the orbits that are increasingly in that order, that is K, L, M, N. So that means if any electron jump from higher to lower orbit, it must emit the energy. So that indicates that when one electron jump from higher to lower orbit, then only we can expect some radiation from the atom, otherwise not. So that clearly indicates that sometimes there will be some emission, sometimes not. That means there will be some dark region, sometimes we are not getting any energy, and sometimes there will be some emission of the energy. So that clearly indicates that why we are getting the line spectrum from the atom. So Bohr's model successfully explained the stability of the atom and also the atomic spectrum, that is the line spectrum. Okay. Now come to the point, the achievements of Bohr's model. There are so many achievements of the Bohr's model. We will discuss one by one. First achievement of the Bohr's model. Bohr's model successfully explained the atomic stability and the Bohr's model successfully explained the atomic stability. Second, Bohr's model successfully explained the generation of the line spectrum from the atom. That means the line spectra, or why the line spectrum that is generated from the atom, that was successfully explained by the Bohr's model. Third point, Bohr's model also explained the generation of the X-ray, the production of the X-ray from the element, that was also explained by the Bohr's model. We will discuss later then how the X-ray was generated and how Bohr successfully explained it. Fourth point, and the most important point, with the Bohr's model we can determine some parameters, like for example we can determine the radius of the Bohr orbit. We can determine what is the expression of the radiation of the Bohr's orbit. We can determine the energy of a particular electron in a particular orbit. What is the energy value? We can also determine from the Bohr's model. We can also determine several spectral parameters like wavelength, like wave number, like frequency, like a Rydberg constant. That all are the spectral parameters. That spectral parameters we can determine from the Bohr's model. And not only that, what values we can get or we can determine from the Bohr's theory, that are good agreement with the experimental result. So that is the another positive side of the Bohr's model. So that all the 4 points or all the achievements of the Bohr's model. Now we will move to there are some also limitations or the drawbacks of the Bohr's model. We will discuss one by one what are the drawbacks of the Bohr's model, and that's why next model came to the field to modify the limitations of the Bohr's model. So first of all we will discuss what are the limitations of the Bohr's model or the discrepancies or the drawbacks of the Bohr's model. Okay, so the first drawback of the Bohr's model. So according to Niels Bohr, or in the Bohr's model, that all the spectral characteristics or spectral features which was explained by the Bohr, that was applicable only for one electron system. What is the one electron system? One electron system means either hydrogen, helium plus, lithium 2 plus, beryllium 3 plus. That all are the one electron system. That means here in each and every case, if you check carefully, that there is only one electron. So that spectral characteristics cannot be explained by the complicated or for the complicated many electron system. So that is the main drawback of the Bohr's model, that Bohr's model is unable to explain the spectral characteristics for the many electron system. Second drawback, The line spectrum, which was successfully explained by the Niels Bohr, and that was the indication of the energy levels in the Bohr's model, that line spectra, each and every line spectra, that are again split it in presence of high resolving power spectrophotometer or high resolution spectrophotometer. If we pass that each and every individual line through a high resolution spectrophotometer, then what happened? Each and every line again split into the small line. So it was not clear that why each and every lines split into the small lines. That splitting, that is called also fine structure. That means hydrogen spectrum that also gives the fine structure in presence of the high resolving power spectrophotometer. So why that kind of splitting occurred? Bohr's model was totally silent regarding that fact. So that is the another drawback of the Bohr's model. Now come to the third point, or third drawback of the Bohr's model. Bohr told that the motion of the electrons around the nucleus was 2D, but we know that electron revolves around the nucleus in the 3-dimensional model, but it was not explained by the Niels Bohr. Fourth point, according to Niels Bohr considered that, or Bohr's model considered that electron has the only particle nature, or electron behaves like a particle nature, but we know after the principle of the de Broglie, or according to the de Broglie principle, electron has the both character, dual character, particle, and also electron has the wave character. So that dual character, that is particle and wave, that was not explained by the Bohr's model. Now come to the fourth drawback. Bohr's model is a contradictory with the Heisenberg uncertainty principle. That means it was not explained by the Bohr's model. What is Heisenberg uncertainty principle? We will discuss in the next class. To understand that there is a principle that is called Heisenberg uncertainty principle, but that was not according to the Bohr's model, or Bohr's model does not support the Heisenberg uncertainty principle. Also, Bohr's model that was totally unable to explain the Zeeman and Stark effect. So Zeeman and Stark effect, that also another kind of splitting of the spectral lines in presence of magnetic field and electric field, which was not explained by the Bohr's model. So that all are the limitations of the Bohr's model, and to solve it by the next scientist, the name of the scientist is that Sommerfeld. So Sommerfeld model we will discuss in the next class, but for today's case, that are all the topics which we discussed till now. Again, what we learned from the today's class? First of all, we discussed about the Rutherford's alpha scattering gold foil experiment. Some statements of the Rutherford's model, we discussed all the statements. Rutherford's model was unable to explain the atomic stability and the generation of the line spectrum. Then Niels Bohr came to the field, and Niels Bohr modified or rectified the Rutherford's model. So Niels Bohr, we discussed about the postulates of the Bohr's model. Then there are some achievements of the Bohr's model also, and there are some drawbacks also there for the Bohr's model. And there are some parameters also, like spectral parameters like wavelength, like frequency, etc., etc., and also some another parameters like radius of the Bohr's orbit and the energy of the electrons in a particular orbit. The dimension of all the parameters we will discuss in the next class. Before that, what you have to do, there are some questions available in the screen. Just you can take a screenshot and try to solve all the question. Try to write down the answer of all the questions, and in the next class I will discuss about the answer of that questions. Then you will check all the answer, either it is right or wrong, then we will discuss the next topic. So take care, goodbye.